We finish our discussion on geometry by covering solid geometric figures. In this section, we look at three-dimensional shapes. The three dimensions are length, width, and height. When we discuss shapes involving circles, we will also include the radius. There are two types of calculations we will consider for these shapes: volume and surface area. Volume measures the amount of space inside the shape. Surface area refers to the area needed to make the shape. When we're looking at surface area, we will also talk about lateral area, which is a shape that maybe is open at the top, the bottom, or both. A cube is a square box. This means that all of the sides have the same length s. To find the volume of a cube, we find the value of the sides multiplied together. We get volume is s cubed. Let's find the volume of the cube in the picture. Each side is 2 centimeters long, so our volume will be 2 centimeters cubed. We know 2 cubed is 8, and now we find that our unit dimension is always cubed. So we know area is squared, volume will be cubed. If we change to a rectangular box, this means that all the sides aren't necessarily the same. Then the volume will be length times width times height. Let's find the volume of this box where I have 4, 12, and 3 as my side lengths. So my volume is 4 times 12 times 3. This gives me 144. Now I have a circular cylinder. Notice it says right circular cylinder. This says it's just standing straight up and it's not slanted at all. The volume of a cylinder is pi r squared times h. So let's take this example where I have a radius of 4 centimeters and a height of 12 centimeters. So our volume is pi. The r was 4 centimeters, and we're going to square it and then multiply it by 12 centimeters. So I have pi times 4 squared times 12. Let's go ahead and give this to 3 decimal places. I have my volume is 603.186, and remember, this is now cubed, so I have centimeter cubed. When we go from area to volume, I want you to see there's a definite relationship between the two. For many shapes, the only difference between area and volume is multiplying by h. You do want to pay attention that some shapes come to a point, and that's going to be a cone and a pyramid. With those, we are going to have to multiply by a third to take care of that point coming in. So let's kind of break this down and show the relationship. Normally, we know a rectangle, the area is length times width. When we turn it into a box, so now I have a rectangular box, I have length times width times height. So I can see I just put the height in there with the area. Same thing's happening on the right side where I have a pyramid. I have length, width, and height again, but because it comes to a point, there's that 1/3 in front of it. Let's look at this with shapes that have a circle related to them. So I have 3 of them. I have the cylinder that we just talked about. We have a cone that comes to a point, and then I have a sphere. So the cylinder, which we had before, I take the pi r squared and I multiply by the height. So there's that relationship between the area and the volume is multiplying by h. That same multiplying by h happens when I look at the cone, but because it comes to a point, I put 1/3 in front of it. And then totally different is the volume of a sphere. The volume of a sphere is 4/3 pi r cubed. So it's the only one that we have in here that has a 4/3 in it. Again, I want you to see that similarity. Things that come to a point, I multiply by 1/3. So both the cone, 1/3 pi r squared, and the pyramid, 1/3 length, width, height. The thirds show me there's a point. Close to pyramids are something called prisms, and I know they're confusing, but prisms are not pyramids. Here's why. It doesn't come to a point, it comes to a line. When you look at the top, I see a clear line across the top. So when I have a prism that looks triangular, the volume is going to be 1/2 base times length times height. Easiest way to do that is let's look at an example. So here is a prism. I have 8 as the base, 9 is the height. I have this 5 is how far it's stretched out, and I have 10 that kind of shows me the hypotenuse. We're not going to use that one. We're going to use 1/2. My base was 8, then my height was 9, and then kind of the length of the pyramid was 5. So I used the 8, the 9, and the 5. The 10, nice to know, but not anything I'm going to use. So you grab your calculator, you put 1/2, 8 times 9 times 5, and you get the volume is 180. Remember, because it's volume, I have centimeters cubed. So let's look at a pyramid. This is the Luxor. It's 350 feet tall and has a square base with sides 646 feet long. Let's find the volume. Right. So we know that this is a pyramid, so I know there's a 1/3 in there. Notice the sides are 646 feet long, so both sides are the same. So this is a square base on this pyramid, and then I have a height of 350. Remember, all of these are feet, so when we're done, we will write feet cubed. But first, I'm entering in my calculator 1/3 of 646 times 646 times 350, and this gives me 4868666.67 feet cubed. Maybe let's put some commas so we can see that this is 48,686,866.67 cubic feet of space inside of the Luxor. So let's do a couple where I give you some time to try and get the answer, and then we'll go over and see how you do. Hopefully you have your formula sheet in front of you to help as well. So the first one, I have a rectangular box that is 12 feet by 15 feet times 6 feet. So try that and tell me, well, kind of tell me, pick which one is the answer. So what would be the volume? So hopefully you threw that in the calculator and you did 12 times 15 times 6, and you got that that is it's 1,080 feet cubed. See if I can put that in a color that you can see it. Okay. In this one, we're trying to find the volume of a pyramid. It has a base of 12 feet by 6 feet and a height of 15. So can you figure out what the volume is? You can always pause me if you need to, so you have time to figure it out, and then you can come back and check your answer. So here's what I see. The volume is 1/3 because it has a point, 12 by 6 by 15, and that gives you 360 feet cubed, which is letter B. All right, the next one, here we have a cylinder. It has a height of 9 feet and it has a radius of 6 feet, so figure out what the volume is. So this is a circle. So circles, I know I have to go pi r squared. So this is pi times 6 squared, and then times the height of 9. So let's try that. Pi times 6 squared times 9 gives me 1017.88, letter D. All right, here's a sphere. Now we only talked about spheres quickly, so let's go ahead and say again, what was the formula? It was 4/3 pi r cubed. Okay, so remember, this is the only shape, the sphere, that has the 4/3 in it. So take a second, figure out what the volume is, and then check the answer with me. Right, so I got that this volume is 4/3 of pi times 2.2 cubed, which gave me 44.60 feet. So that's letter C. Oh, not feet, sorry, centimeters cubed. Once again, I have the volume of a sphere, so I know my volume is going to be 4/3 pi r cubed. Really important that for this one, we notice that we weren't given the radius to start, we were given the diameter. So you need to divide the 42 by 2, make it 21 before you put it in your calculator. Now that I have the radius, I can put 4/3 pi and then 21 cubed in my calculator. It gives me 38792.39, and this would be centimeters cubed. When I look, I can see that's letter B. This is a volume of a cone. So cones, remember, because they come to a point, they have a third. Then I have a circle, which is pi r squared, and then I have the height. So let's try putting these dimensions in and see what we get. I have a third, pi. My radius is 4, and then the height is 9. So I have 1/3 pi times 4 squared times 9. This gives me, let's write it at the bottom, 150.80. I had 796, so I rounded up, which is letter D. So after we've got the volume down and we know how to use our formulas, we also want to make sure we talk about the measure of the outside of our shapes. So this we call surface area, and I like to start with a cube because I think it's the easiest one to see. So what I want you to notice in this picture is that I've looked at each piece of a box, and this happens to be a square box. So look at it like column by column. So notice I have a top and a bottom, that's 2. I have a front and a back, that's 2 more. I have a left and a right, that's 2 more. So I have 6 sides that make up this cube. Well, all of the sides happen to be squares, so I know each of the sides are s squared, and because I have 6 of them, because there's pairs, then I have the surface area is 6 times s squared. So that would say if I wanted to make a box, say I was picking up pieces of cardboard or picking up pieces of wood or something, and I'm trying to construct this box, this would tell me how much material I need in order to make this box. So let's find the surface area of the cube. That's 2 centimeters on each side. So remember, our formula says it's 6 times s squared. So I have 6 times 2 squared. 2 squared is 4, 4 times 6 is 24. Important to look at what dimension do we have, like what kind of unit am I putting under it. I'm still going to go squared because this is area, so it doesn't matter that it's surface area. All area always comes out squared, so you don't have to worry about is it squared, is it cubed, what's going to happen. It's squared because it has the word area in it. Let's make this slightly different and make it a rectangular box. So this difference is all the sides aren't the same, but I still have pairs. I have a top and a bottom that are going to be the same. I have a right and a left that will be the same. I have a front and a back that will be the same. So do you see how I have 2 and 2 and 2? There's my 2, 4, 6. I still have 6 things going on. So the top and the bottom, that's my length width. The 2 shows top and bottom. If I look at the right and the left, that's where the 2 WH comes from. Each side would be WH. And then the front and the back is my 2 LH. Order doesn't matter because it's multiplication and addition. So if you write it in a different order, that's perfectly okay. But I do want you to see there's doubles of everything, and that's how we're making this box. Again, let's take an example. So in this example, to get my surface area, remember it's 2, so the bottom would be 10 times 8. And then 2, I could go the left and the right, which is 8 times 12. And then 2, I would have to do the front and the back, kind of the faces, and that would be 10 times 12. So it's like I do every pair that I can. So then that goes in the calculator. Be careful that you put your multiplication and addition in, that you pay attention to when did you switch. So I have 2 times 10 times 8, then plus 2 times 8 times 12, plus 2 times 10 times 12. This gives me 592, and once again, this is centimeters squared. Okay. For a cylinder, well, I again kind of look like I did with my boxes. There's a top and a bottom. That's why it's 2 pi r squared. The bottom is pi r squared, the top is pi r squared, so there I have 2 of them. The 2 pi RH is if I took this can and I were able to cut it. So let's say we cut it like maybe along this edge. If I cut it and opened it up, it makes a square. Or not really a square, it would be a rectangle. So with this rectangle, same height, but this part along the top, part along the bottom would be equal to the circumference. I've unrolled the circle, which is 2 pi r. So I have the circumference times the h. That's where the 2 pi r h came from. So if you wanted to know like how'd they get this formula, it's really just through construction. So we can use that. Once we have a formula, we can use it, and we can find the surface area of this shape where I have the radius of 4 and the height of 12. So my surface area is 2 pi, and then the 4 is squared, and then 2 pi, my r was 4, and then my height was 12. So again, everything just goes in the calculator. My surface area is 402.12 centimeters squared. And I told you there'd be this other thing called lateral area. So lateral area is a kind of surface area, but the difference is the things aren't closed. So closed means I have a top and a bottom. Lateral, something's open. So you can see I have this picture of pipes, and pipes would be open, right? So we can connect them. So I have open on both ends. That's a type of lateral. And then I have this cone that's not closed. It's a water cup, so I could put water in it, right? If it's closed, I can't put any water in it. So these are where we're looking at the outside of how much area is there, but I don't have them closed up. So let's start with looking at a cylinder. If I don't have the top and the bottom, all I have is that part, right, that I said that I could unfold and make as the circumference times the height. So no 2 pi r squared, just 2 pi r h. So let's say we had a pipe that had a diameter of 5 feet and a length of 24, and let's find the lateral area. Notice it says diameter, which means the radius is 2.5. So I have 2 times pi times r, which is 2.5, times the length, which was 24. The length and the height, same thing in this case. So I have 2 times pi times 2.5 times 24, which says our lateral area is 376.99, and this would be feet squared. Still area, so still squared. Lateral area of a cone, we're bringing in the slant height, which we've talked about as the hypotenuse before. So it's how far is it on this angle. So we're going to use pi, we're going to use the radius, and then we use s, which is the slant height. So let's find the lateral area of this cone. So we're going to call it s. It's pi, the radius is 5, and my slant is 13. I have pi times 5 times 13, which is 204.20. This is in meters, so it's meters squared. And one more, just to make sure we have it. In this figure, I have 18 as the height, 7 as the radius, but notice I didn't give you the slant height. So before we can go about finding the lateral area, we have to first find this missing side x. What does that make us do? It makes us go back and use the Pythagorean theorem. So I know 7 squared plus 18 squared is going to be x squared. So I'm going to put 7 squared plus 18 squared in my calculator. It gives me 373 is x squared. And then I'm going to take the square root, and it says it's about 19.31 is x. Okay. So now I have my slant. Now I'm ready to do the lateral area. So lateral will be pi times my radius of 7 times the slant, that's 1931. Which gives me a total of 424.65. Let me write that right here so you can really see it.